Hello everybody and welcome to our last video that's going to help us understand the concepts of position, velocity, and acceleration in the context of calculus. So there are a couple new vocabulary words we're going to introduce here. One of the things that you will often be asked to analyze is whether your object or particle is moving towards or away from the origin. It's important to remember that in calculus, almost everything is traveling along a horizontal line. So the particle is sort of bouncing back and forth on this line. In order to determine whether you're moving towards or away from zero at any given time, you need to look at both the position and the velocity. And once you have those two values, you need to analyze what you have to sort of see which direction you'd be going in. For example, if your position at a certain time, let's just make this up, like 2, is positive 5, and your velocity at the same time is negative 6, then on a number line, right now, you're standing on the positive 2, but since your velocity is negative, you're headed in this direction. In other words, you're going towards 0. If your velocity ended up being a positive number, you would be standing on the positive 2 but going to the right, which is away from 0. So you need to kind of analyze position and velocity and draw a picture in order to figure this out. In order to figure out when you're furthest from the origin, in other words, kind of when are you farthest away from 0, you will need the maximum and the minimum position. So in order to do that, you're going to take the derivative of position, because in order to find a max or a min, you always take a derivative. You set this equal to 0. You make an options chart, including the endpoints. And then you find both the highest and the lowest values to determine which one is actually the largest. So farthest from 0 could be in the positive or the negative direction. In other words, you need both the max and the min to see which one is actually farther from 0. So let's go ahead and do a couple examples. So a particle moves along a line so that its position is given here, where s is measured in meters and t is measured in seconds. At t equals 4 is the particle moving towards or away from the origin. In order to determine whether we are moving towards or away from the origin, we need both the position at 4 and the velocity at 4. Now position we can figure out straight away because we have a position function. So 4 squared is 16, minus 12 is 4, plus 1 is 5. My velocity function here, if I take the derivative, would be 2t minus 3. So the velocity at 4 would be 8 minus 3, which is 5. If I draw a visual, that means I'm standing on the positive 5, and I have a positive velocity, which means I'm going to the right. Since I'm going to the right, I'm heading away from 0. And I would say because at t equals 4, the particle is headed away from the origin, because the position at 4 is 5 and the velocity at 4 is positive. So I'm going to the right. At t equals 1 is the particle moving towards or away from the origin. So again, we're going to need both the position at 1 and the velocity at 1. The position at 1 I can get by just plugging my number straight into my position function. So I would have 1 minus 3, which is negative 2, plus 1 is negative 1. The velocity function that I had here, I'm going to use again here, and the velocity at 1 would be negative 1. So on a number line, I would be standing on the negative 1 and going to the left because my velocity is negative, which means I'm going away from 0 again. So I would say at t equals 1, the particle is moving away from the origin because the position at 1 is negative 1 and the velocity at 1 is less than 0. It's negative. At t equals 1, that's the same question, so we're going to go ahead and skip that one. Sorry. Over the interval from 0 to 2, when is the particle furthest from the origin? Whenever we want to know if we're furthest from the origin, we're looking for maximums and minimums. So we're going to start by taking the derivative of position, which is the same thing as velocity, which is 2t minus 3. Now we're going to make that equal to 0, so we're going to have t equals 3 over 2. We now know that our maximums and our minimums are either going to be at the endpoints or at this number. So we're going to make what's called an options chart. I'm going to list the potential places, the t values, where those maximums and minimums could occur. And I'm going to find my position at each of those values in order to see which one is the biggest. So at 0, my position is 1, if I plug that into my position function, which I had here. And at 2, my position is 4 minus 6, which is negative 2, plus 1, which is negative 1. At 3 over 2, I'm going to have to actually calculate this out. I'm going to have 9 over 4 minus 9 over 2 plus 1. Now the common denominator here would be 4. So I would have 9 minus 18 plus 4, which is negative 9 plus 4, which is negative 5 over 4, which is negative 1.25. Okay. Of these numbers, 1, negative 1.25, and negative 1, which one of those is farthest from 0 on a number line? This guy. So, over this interval, when is the particle furthest from the origin? At t equals 3 over 2. And this is measured in seconds. All right, that is it. Thank you guys so much for watching, and I will see you for some practice. Have a great day.